think we're going? Because I didn't get the 3, 2, 1 countdown. This is what we're doing today. Yes! I stole this off the internet. All right, but it was the first thing that came up, and at least what I did, though, is like peruse it. Is this really good for what we're doing? And I thought it was excellent with a couple additions that I put myself to make it more pre-calculus, because I think this is more like Algebra 2. So off to the right, this is our section 2.4, which you'll see on the slide. So what we're doing today is long division. Then do you guys remember synthetic division? Huh? They do have something to hand out for you that coincides with what we have here. Blah blah blah, and then what's something that's called synthetic substitution. So there's 3 things. We're going to do long division, we're going to do synthetic division, and then we're going to do what's called synthetic substitution, which is a minor little thing next. Okay, now I do have this up here. I won't be able to do, well, I'll write this. I guess I could write this and then maybe it won't go away, but where do I have it? Oh, I have it right here. So the first thing that's going to come up is this, and I will write it on this video. So, and I really hope this is taping. I don't know. We'll find out later. Do you remember this kind of question? And I'll probably try to erase this. 277 divided by 12. Why is he teaching me this? Because you know what? What we're doing today is exactly like this grade school example. Right. So when you were, this is Krabappel, a nice teacher, when you love school, you love coming in. What did she tell you to do? Didn't she tell you to make a little division garage? Oh my gosh, I don't know why that line just came up there. You know, here we go again. Samuel is battling technology. Remember that division garage? Who goes in the inside? 277. Who goes out on the outside? 12 with a big line through it for some reason. Okay, and then what did you do? Didn't you first say, okay, how many times does 12 go into 2? Does that work? No, then the next one, 27. What happens? Twice. But then what do? You multiply, and then what do you do next? That's what you're going to do when you're dividing polynomials. All right, and it's going to be really showing you. I gave you 2 examples, one from them that I added markings, and then one I just made up with this PowerPoint. So subtract. Then what do you do with that having that 3 there? Bring down the 7, and then you do it again. Sorry for so shaky. That's how shaky I am. Nervous around the students. All right, and then what do I do? How many times does 12 go into 37? 3. And then this is 36. And then what do you call 1 after you subtract? And then back in grade school, you'd call that R1 first. Then maybe the next thing you were told is you could write this as 23 and 1 over, anyone remember? 12, 1 over what you divided by. And that's one of the 2 ways you're going to write your answers when you're dividing polynomials. Okay, so I'm going to erase that. And then it's going to come up from their PowerPoint just so it's out of the way. Hopefully this all shows up very well on our thing. There you go. Okay, so on the PowerPoint it shows that without the subtractions, it assumes that you subtract. We're going to write the subtractions when, don't write this down. You are long dividing by a polynomial, it looks exactly the same. You see that? Okay, so that's how it's going to look for you. All right, with the same processes, but a little bit of difference. Okay, fine. I always say Lexi could do this. She can't do the one on the right. Lexi can do the one on the left. You can do the one on the right because you have some algebra skills, and that's all that it requires. What algebra skills? What algebra skills? What's x squared times x? Uh-oh, no one answered in 4th hour. What's x squared times x? X cubed. What happens when you have minus a binomial? You no, not divide. When you have minus a binomial, you distribute. All right, you're just using D words. All right. All right. So don't write this down. This was, I think, out of our book. If you look at it, there's another example. What I want you to get out of this slide is the 2 forms that you can write your answers. One form is what I intimated on the last slide, fraction form. So let's do fraction form first. Let's just tell you why I showed you this, and you don't have to write this down. I should not have you writing this down except for the bottom half of this slide. Just know that this is the grade school example. And then, 3587 divided by 32. And you get 112 with a remainder of 3. So fraction form is answer plus remainder divided by divisor. With numbers, we know that's just 112 and 3 32nds. We just smush them together. But it is that little plus there. And 3 and 32nds. That's how you read that. 112 and 3 32nds, which is the plus sign. For polynomials, okay, don't write this down. Don't write it all down. Just say, okay, if I divide these, this is the answer up on the top of the division bar. So what that implies is this answer in fraction form is 1x squared plus x plus 2 plus. You got to add that plus sign. You don't put that plus sign, I'm marking you wrong for math syntax. Remainder over what you divided by. Do you guys remember this? Okay, good. All right, but we do have to go through it. It's a common problem. And this is why I say all the things that we do throughout the year, we're practicing those common skills of algebra. So those that are struggling in my class right now, it's the common skills. So now we just have a little different thing in order to do that. Now down on the bottom, this form I'm not as big of a fan of, but this book asks for it. And I believe we'll be asking for it, on our next test, potentially. Polynomial form is this form. Divisor, what did we divide by? 32. I don't know why that didn't highlight there. Times quotient. What's the word quotient mean? You see me trying to highlight that, right? I think we're going to have a problem here. This is when the program starts locking up. All right, and then I did not do that. Oh my gosh. Where are we at? What happened? Houston, we have a problem. Okay, there we go. It came. There it is. Quotient's highlighted. Quotient means answer to a division statement. Plus the remainder all by itself. This highlighting isn't working again. So plus 3 was that remainder. All right, let's look over at the polynomial. I'm going to stop trying to highlight. I feel like this is, there we go again. I think a ghost is in the room and it's taking control of the PowerPoint. This is why I don't make movies, guys. It's honestly why I don't. The technology has gone down the tubes. All right. So anyway, the divisor is 3x plus 2. The quotient is x squared plus x plus 2. The remainder is just plus 3. This is what students don't like about that. It's not 3 over the divisor. And what you can be sure of, as I'm pointing down to the bottom, because I'm not going to highlight anymore, is if I multiplied these two out and then added 3, you would get what the dividend was, which is what's inside what you're dividing into. Okay, so we'll look at those two forms as we go through each example. All right. Now go and write this down, and this is the stolen off the internet, 6.3, probably from an Algebra 2 book. What's Algebra 2? All right, so I'll give you a second to write this down. And purposes, I can't really pause the video. It says I can. I don't think it works. So I'm just going to proceed on. So first step, and it does step this out very nicely, and this is imperative, that you put this in descending order. Now, the reason the next part's going to be imperative is because when you do synthetic division, it is not an option. You have to account for missing terms. So not only do I write the dividend using a math term, the thing that's being divided into, the thing that's under the garage, you write it in descending order, and in addition to that, account for missing terms. Now, you don't have to do this separately. If you read this in the book, the very first thing you're going to put on your paper is the division garage. The next thing is you're going to put this under the division garage in descending order with 0, counting for any missing terms. So this is just for notes, stepping it out for you, nice and easy. That's what I do as a teacher. That's why I love when people make, I don't like his teaching style. What, the one where he goes step by step to explain every possible thing you could possibly run into in order, it's the worst. It's the absolute worst teaching method ever. All right, Right. Sorry. Write division in the same way you would when dividing numbers. Okay, and then that's what you're going to build off of when I show the work. So this will just be on the next screen. I don't think you really need to have that as a. Do we have a sleeping student? How dare you? Do you have an A? Oh, actually, he does. Never mind. You're fine. You need to go to sleep. Remember that girl I said that would read Harry Potter every day in class? Okay. So we'll leave you. We'll leave you be for a second. Okay. Oh no! It already started the division process. Okay, but I'll actually arrow it out for you to see, how come this person came up with 2y squared on the top. And I don't like what they did. I like that 2y squared above the y squared, so you know how many steps you might have. Maybe. Sometimes it doesn't. Watch the next example. Well, where did that 2y squared come from? It came from the grade school students. When they asked, what, I think I did this perfectly, what, I hit it. What, I hit it. Why is it not working? There we go. What times y equals 2y to the third? Okay, so that's what you focus on in algebra land, not in, the little number land where I think, what do we have? 12 goes into 27. Was that our first thing we had to think of, right? Okay, well how does y go into 2y to the third if it's multiplied by 2y squared, right? You got it? But now here comes your algebra skills. You distribute the 2y, and then grade school says you subtract, right? Okay, so I distribute the 2y squared. That's how I get 2y to the third minus 6y squared. But then grade school says you subtract. That's why that minus sign is sitting out in the outside. And that's what they did, not me. And that's correct. That's why I love this slide. I'm giving, if you're out there on YouTube and you say, hey, those are my slides. Sorry, but it was free because it was on the internet. So I took it. Then you distribute the minus sign, and then someone was crinkling their face. How'd they get that 5y squared? What's a negative 6y squared? Positive 6y squared minus y squared is 5y squared. Now, just like in grade school, when we had to bring down the next number, we have to bring down the 0y so we can continue the process. Now, I think I did this one in nice order. I use the arrow this time. Nice. Now, the next analysis is, they already wrote the answer, though. Shucks. Where did the 5y come from? Well, the next analysis is, how does y go into 5y squared, the next level? It would have to be multiplied by 5y. And then you start with a D, everyone say it, distribute the 5y, and then what do you do next? Subtract. He just said square. He's just saying S words. You subtract. I'm standing in the front of the class to not, have my finger show the minus sign distributed. Negative 5y squared and 5y squared cancel. Negative 15 minus, or negative 15 is positive 15y plus 0y. So the next thing you're going to see is 15y, and then bring down to 25. But I didn't write that now. I wanted to time this correctly. So we know in this circle here, 15y shows up. So I want, what's the next number? What times y equals 15y? What's the answer to that? Just a 15 goes in the blank up there. And now they'll come in when they show the rest of this. All right, so they do kind of, they time it out real nice. I made the next one with the order of steps, and it goes a little bit clean, not cleaner. I don't want to rip on this, but I just in a better order so we can think about the things before they appear. That's what I mean. So again, the red, green, and blue lines, or the lines that came up in order, show how you think on the next step. And then the only thing that people screw up on this is not subtracting and not distributing the minus sign. That's it. Don't tell me this is hard. Then you're telling me you don't know how to multiply polynomials. You don't know how to subtract them. And these are the skills that I have seen be a problem. And there we go again. We get more practice at it until people stop making those mistakes, and then the rest of the year should run smoothly, right? Okay, and that's really the truth, not being mean. And if you feel like I am being mean, I bought the stress bear up at the front, the Star Wars stress bear. All right, you can hug it. You want it? You want the bear? You want to hold it for a little bit? Okay, I'll go get it as I show the next example. Okay, now, all kidding aside, here's how you write the final answer. Now, I didn't wash it, so I don't know. I got it from Goodwill, so you're at your own risk. There you go. All right. That'll give you comfort as we do the next set of notes. Take that hood off, sir. You're not in the gang. All right. All right, now, I'm going to attempt this. This is fraction form. Here's polynomial form. And I did write this in the other. Here's polynomial form. Okay, so it's what you divided by times the quotient, which is this 2i squared. And I understand what you're going to ask me next. First, I'll ask this to a student. And then close it off plus the remainder separately, not over, not the remainder over the divisor. And that equals what you divided, what you first divided by in the first place, which is this. Okay, and that's what polynomial form is. Now, just write that. And if you don't want to listen to the next part, just put your earmuffs on. If you wanted to write it like this, that's okay. Then it would have to be over y minus 3. All right, but polynomial form says no. You want to write it like that with the remainder all separate, so it should be like that. The remainder totally separated outside. I'm not a big fan of the polynomial form, but they do ask you to do that in your homework. Then if it is an odd and you look in the back of the book, that's how polynomial form is going to look. Okay? Is that a question? Oh no, we'll have to do it live because you should know both. All right? All right, so I pulled this one out of the book. It's actually example 1 in the book, and it's more of a cat's meow question because it has, a little wrinkle in there. So use long division to find the quotient and remainder when 2x to the fourth minus x cubed minus 2 is divided by 2x squared plus x plus 1. That's a cat question. You're not dividing by a binomial. You're dividing by a trinomial. It's still the same analysis, but what happens in this is a little weird, and I want you to be prepared for it. So there's the question. As you're writing down, are you missing any terms? Are any terms missing? What do we do to account for that? For long division, the purpose of this, and by the way, my math symbols, is that the right symbol for division? No, what symbol is that? Square root, so I made a change. There you go. I colored in to make it look like a little, there you go. Now we got to, with our math type, I couldn't find the division garage. But anyway, you want those missing spaces for space on the answer bar. And then it's a good habit because in synthetic division, you have no choice. If you don't account for missing terms, synthetic division will not work. All right, and then look at how I did this. I color-coded it already. That's what you focus on. The grade schooler, how many times does 12 go into 27? Well, the cat student, how many times does 2x squared go into 2x to the fourth? Or a better way of saying it is what times 2x squared equals 2x to the fourth? What's the answer, everybody? X squared goes on the top, and then you distribute it through the trinomial, and then subtract. This is it. Don't tell me you can't do this. This is basic distribution using powers. So 2x to the fourth plus x cubed plus x squared, then subtract. And then you got to filter that negative all the way through. Negative 2x to the fourth plus 2x to the fourth is gone. Negative x cubed and negative x cubed, what's that? Negative 2x cubed. And then negative x squared plus 0x squared is negative x squared. Then look at what I did. Ooh, did you see the polynomial on the left change? Because I wanted to figure out a way to color code. Now here's your next analysis. All right, and then you do bring down to 0x, and you can bring down to -2. It's just not going to play yet. All right. I hope there's no mistakes at this point. I don't think so. We look good. Just giving my class a chance to catch up in the notes. And now I had the divisor change colors, because now I look at the new leading degree within this question, and then ask the question, what times 2x squared equals -2x to the third? What's the answer to that? -x. That goes up at the top. You write it as a polynomial minus x as the next thing. If you want to make it plus a negative, that's fine. And then you distribute, and what? Distribute, then subtract. So this is grade school with Math 3 combined. No, Lexi and Sammy Samuelis cannot do this. And I know Brianna can't either. But if I taught, she could probably be taught this brand new and actually do it. She knows how to do the powers and stuff and subtract. But it would be a tough one. But just keep it slow, man. Just do those 2 steps and it's not really that bad. Hey, what do all these negatives become? Positive. And oh, look at the middle term. Doesn't that cancel? So you know what ends up happening? Something weird. This is why I did this one. This is this is what you have. Now look at the divisor. It's 2x what? Squared. Whenever the divisor, like we lost our x squareds on accident, you know, so we lost that. This is over. This is actually, watch, this is the remainder because it is 1 degree less than the divisor. And that's why I did this one, because it is a little bit unique. Okay? All right. Now I cut this out of the book because this is the question out of the book. I cut polynomial form and I cut their fractional form. And it may be a little bit hard to read, but I highlighted it real quick. Polynomial form. Divisor times quotient. Now it's just in parentheses because the remainder is a binomial. So plus remainder. No division on that. Whereas fraction form, that's probably too dark of a highlighter, isn't it? My bad, dogs. Okay. Well, fraction form is answer x squared minus x and then plus remainder over divisor. And that's what I have highlighted in blue. All right. So we have to give the class a minute to do that. I wish I could pause the video. I'm just nervous. Everyone okay out there? This is the hard part of the section. After this, we're doing synthetic division. Oh, okay. I guess during the pass out these sheets I gave you, I really liked what they had on this. So do you want to pass those out? Looks like you're about to fall asleep anyway. Are you? You didn't look behind your yesterday, did you? Okay, good. What I would do is just pass it as much as you need up to the, okay, you can snake it. That's fine. Is everyone done writing that down? Hey, if you're on YouTube watching this, just fast forward. You know, all these parts that are useless. Because I do have some that are writing still. Just want to make sure. Okay, so what you have in front of you is the next slide. So you don't have to take, and you may not even need it. You can put it in the recycling as you walk out if you want. Okay, but I figured those that don't know synthetic division, you could look at that as a cheat sheet. But I do actually give this props for what they show you. Okay, and I don't want you to write this down. And back in the day, I wouldn't say I derived it, but what I did is I did a long division question. Then I showed, hey, here's this weird synthetic division, and then let's make some correlations between the long division answer and the synthetic division answer. And it took a long time and nobody cared. All right. So let's just accept that you know what short division is. It's a shorthand method of dividing a polynomial. This is completely them. by a linear binomial, and that's what's important. Did you see that? Synthetic division only works in a special case. If you have a linear binomial, if you're dividing by x plus or x minus a number, when it's 3x plus or 7x minus, then there's a wrinkle. There's a problem with synthetic division. In our last example, did we divide by a linear? Yes or no? No, we divided by an x squared, not an option. Synthetic division does not work for our last example. So it's very unique circumstances that you can divide by synthetic division. But when you have them, do it. It's great. The polynomial must be written in standard form, and you must use 0 for any missing terms. All right, so here's what you have in front of you. Didn't we do that, right? All right, so let's look at this real quick. 2x squared blah divided by x plus 2. The very first thing is weird, but what you need to do is find the 0 of the divisor. That's kind of what's said in step 1. So I'm dividing by x plus 2. I must synthetically divide by -2. That's number 1. Then number 2, that's the classic look of synthetic division. Put it in that little square there. First step is bring down the 2. Next step is just multiply, add. No subtraction like in regular division. Just -2 times 2 is -4. Add them, get 3. -2 times 3 is -6. 3 ends up being the remainder. And then what we have is what's called a depressed polynomial. You know why? Because the polynomial 2x squared, just like Mr. Samuelis, is not what it used to be. It's been knocked down, not only by life, but by this binomial. It's been knocked down from a degree 2 to a degree, anyone? 1. Right? And then that's why we have 2x plus 3. These are the coefficients of the depressed polynomial. And that last 3 is the remainder divided by x plus 2. So here we go. We're going to take this one. Now you can write this down. You don't have to write example 2b or, do whatever. You just say divide by synthetic division. 6.3 Algebra 2 book, our section 2.4. Love this. It's actually the first one I found. What did I put? Dividing polynomials, or I think I put on Google. PowerPoint. And this was number 1. Hey, if it's on the internet, it's for everyone. You know that, right? When you put something on YouTube or Google, they own it. It's out there. You signed your rights away. Are we missing a term? Is it in descending order, though? If it's not in descending order, you better watch yourself. All right? So we're missing a term, so you must account for it. Oh, okay, they did this first. Again, we're dividing by x plus 2, so we have to find the 0 of it. -2 is what goes in the blank. And then write this like this, and this will go on the next slide. But as long as you're in descending order, 3, x to the 4th, -1, x to the 3rd, and then 0x squared. You don't write that 0, you're done. It is impossible to get a right answer in synthetic division. It is not an option. Now, I did notice in our book, they do explain, if you really care, they do explain why synthetic division works. I just noticed that. I don't know why I'd never read that before. And looking at how to construct these notes a little different today. So anyone that goes above and beyond, you can look that up. It's actually pretty interesting how the process works and why it works. Oh, that's cool. All right, you'll see this on the next page. And I think they do the first step. Nope. Okay, so that's all we had, right? So how do you start the process? Just got to remember, some people mess up the first step, and then if that's messed up, you're done. You just bring down to 3. That's what happens first. And then you start the multiply add process. -2 times 3 is -6. Then you add them. -2 times -7 is 14. Then you add them. -2 times 14 is -28. Then you add them. -2 times -23 is 46. Then you add them. Okay, and I think, yeah, okay. So it's new. I like that. Whoa. Take it easy over there. I'm old. I just slammed their books on the ground. Scared me. I might need the bear. I'm fine. I'm fine. You hang on to it. All right. So 45, so what happened? This was, I'll get the out again, because we'll talk about the depressed polynomial thing again. Aw. This was 3x to the fourth. What the heck? That was supposed to be my arm hit. What is going on? I hit 10. Okay, let me see one more time. Oh, maybe I didn't. All right, fine. This was x to the fourth. Now it's depressed to an x to the third. I'm having a hard time writing. So now that's 3x to the third minus 7x squared plus 14x minus 23 plus 45 over what you divided by, which is not negative 2. You emulated dividing by x plus 2. So it's 45 over x plus 2. And then polynomial form, I think I still have the pen. Nice. Would be you divided by x plus 2. Here's polynomial form. The quotient is, I gotta watch my hand hitting the screen or else it'll make this PowerPoint go to the next. It's very touchy what I can do. This is polynomial form. Close it, and then it's just the remainder tacked on at the end. That's what students don't really like. But I assure you that if you multiplied this out, got everything combined, and then added 45, it would equal this 3x to the fourth minus x cubed plus 0x plus 5x minus 1. And that's the point of polynomial form, I guess. Okay? Shall I move on? Nah, we're not going to do it. But notice what you can divide by: x plus 3, x minus 7, x, then you just synthetically divide by x minus or negative 3. I guess I'll show it real fast, right? So this is what you would do, right? And then you get doink, doink, doink. Then we'll just write fraction form. That's a simple one. That's more like an algebra 2 basic. Okay, I cannot overemphasize. You cannot do synthetic division with that. We'll get there. Stunning video. Okay, then the last thing. This is another reason why I like this slide, and we're going to go to the end here. Okay, you can use synthetic division to evaluate polynomials. So therefore, the process is called synthetic substitution, which is the same process of synthetic division, but the final answer is interpreted differently. And this thing does an awesome job of describing this. This shall be called the remainder theorem. Can everyone say the remainder theorem? Because at the end of your homework, it says use the remainder theorem to evaluate the polynomial for the given x value. So watch how they break this down. And that maybe you have to go to the, don't write this down, look at the end of the notes if you want. I just wanted this to be really thorough so that you can't complain about, I don't know what he's talking about here, right? Because we could always watch this again. So if you divide this polynomial by x minus 3, you'd have to put 3 in the blank. Then go through the multiply-add process. What this means, though, the remainder, it means if I input 3, by the way, input what? The remainder is the output value. It's the y. So that's what synthetic substitution does as well. So not only does it divide polynomials, it inputs, anyone? Outputs, right? And that's what the remainder theorem says. And I think by saying input output over and over again with you guys, it shouldn't be an issue. I should have put this on the back of your, this is an illegal phone call. I was going to put my ringtone in the movie. My phone rings randomly, sorry. Illegal. I just tell people to put their phones away in my class anyway, so it's not like a big phone jerk. Does this say x minus 2, or what does it say? X equals 2. What goes in the bar, 2 or negative 2? 2. Okay, when you're dividing by a polynomial, a binomial, then you find the 0. When you're doing synthetic substitution, they say x equals, and then that's the number that goes in the thing. Okay, now what this is saying, and this does do a good job of explaining this. I'll use synthetic substitution. I'll drop down the 2, multiply, add, multiply, add, multiply, add, but now the interpretation of this answer is different. I actually inputted what number? Input is what? 2. What's the output? Y now? 41. Now I could write that as a coordinate or like this. And yes, I think this does do it. This would have been the same if you did this, but if I ask you to do synthetic substitution, I better not see the work I see below here. Do you understand me? All right? But that's what it's replacing, and that's why I think these slides are amazing. I just added a couple of cat questions with it. So whoever you are out in the internet, whoever I stole this from, thank you very much. Is everyone okay? We got a sleeper. I won't punch the cabinet. Not today. I'll give you a break. You still want that hood. Is it really that cold in here? Okay. I was going to give a synopsis. I'll go back in this class if you wanted to finish this slide here, but not that one. This is what we did today. We divided using long division, then we divided using synthetic division, and then we talked about synthetic substitution as a replacement for, right? And that's it. That's just a nice little synopsis. We don't have time to use this as a lesson quiz. It could be our bell work tomorrow, though. Hey, what a great idea. All right, and then I'll end the film. How do I end this? This is fun. Okay, I guess I go, don't look.